Good afternoon. I am Dheeraj Patle. I am TA for this experiment, a boiler, and the course name is EN 310. Let's start the theory behind the boiler. Our objective here is to know the operation of boiler and to calculate the thermal efficiency or operating efficiency of a boiler. In this case, we can see these two diagrams. This is basic diagram for boiler. Boiler is a closed vessel device which is used to heat the fluid, and there are various applications of boiler, and this is very simple experiment, but the use of this boiler in the industry is very vast. Just like we can take an example like steam bath in the large hotel and food processing, like this various applications are there. So we can see that in this diagram the boiler has a very basic concept which is heat transfer. If you know the heat transfer, there is nothing more than that in this boiler. So basically, in first diagram we can see that flue gas inlet is there and flue gas outlet is here. This is water inlet and water outlet. So flue gas is a high temperature gas which acts as a heat source. So in this case, so flue gas, high temperature flue gas will be flowing through this path, and water has an ambient temperature. So if you pass this water in this shell, then the heat transfer from that high temperature to the lower temperature will be there. So water temperature will be going to increase, and whatever the water outlet will be there, that will be a higher temperature. So in second diagram, this is our experiment. So our experiment setup is like this only. We can see here the burner. So burner will be burn the fuel, and it will generate the flue gases. The flue gases will be going to this small portion, the circular portion, and that circular portion is in this diagram. You can see that the flue gas inlet is this one. Okay, this is burner, and burner is used to ignite the fuel, and that fuel will be after ignite of that fuel, we will get a flue gases which is high temperature like 170 to 180 degrees Celsius, and it will pass through this tube. So from this tube, from this inlet, it will pass through up to end, and then after that again it will pass from end to start, travel from end to start, like this it will travel through this path. So in this case there are three paths: first, second, third. So this is three paths boiler, and after that it will be going to a exhaust. There are two types of boiler, fire tube boiler and water tube boiler. So in fire tube boiler, if the flue gases or fire will be in the tube, then we can call it as a fire tube boiler, and if water is there in the tube, then we can call a water tube boiler. So basically fire tube boiler is the application of fire tube boiler is limited. Like if our capacity is small, then we can use the fire tube boiler. If in industry they has a very high capacity of application, so we need a higher amount of volume of steam. So volume of steam and the pressure. So in that case we can use the water tube boiler. So our experiment is a fire tube boiler which is of 750 liter capacity and 10 bar pressure. So that's it. So we have two methods to calculate the efficiency. First one is direct method and second one is indirect method. In direct method, we just calculate that how much heat will be absorbed by the water divided by heat given by the fuel. And in indirect method, we use the losses concept. So we calculate all the losses and in terms of percentage, and we just subtract from the 100. That is the indirect method, and we are going to use the indirect method here to know better the quantity of losses, so that we can visualize things and we can quantify the losses which are more important and major, or we can say that minor. There are two major losses like flue gases and surface losses. Also there are leakages also. So we are going to neglect that thing. First of all, the flue gases will be like MF into Cp of flue gas into T2 minus Tin. T2 is nothing but exhaust temperature and Tin is nothing but ambient temperature. MF is nothing but the mass of flue gases. So mass of flue gases consist of CO2, SO2, excess O2 and N2 in the air supplied, because it is not going to be reacted. So it will be like a ideal. So N2 will be as same as inlet. So if we add all these things, so we can get with the help of stoichiometric equation like C plus O2 CO2 H2 plus half of O2 H2O, like that we can calculate the formula, and with the help of this we can calculate the MF, and from this we can get a flue gas losses. Second thing, surface loss. Surface loss is nothing but the radiation plus convection. So in this case HADT is nothing but the H is coefficient of convective coefficient or radiative coefficient. So H is combination. H is nothing but H combination here. So we have to use a certain formula in the manual. So we can calculate, we can combine all the radiation and convection formula all together in the one formula only. Second thing, the calculation of X, because we need a X here because of O2, excess O2. So with the help of oxygen sensor, we will get a excess O2, and with the help of excess O2, we can calculate the how much kilomole of oxygen is present in the exhaust gases. So in this formula we can use this. So O2% of excess we can get from the oxygen sensor, and this is nothing but a formula X into 100. This is a kilomole of oxygen in the exhaust gas, and this is nothing but the total exhaust gas composition. So here everything is there like SO2, CO2, N2, O2, like all these things. So we can calculate that X with the help of this formula, and after that air external can be calculated, because in air there are 21% of oxygen is there. So we can directly calculate it with the help of X divided by 0.21, and but this is kilomole, so we have to calculate in terms of kg. So we just multiply molar mass of oxygen, and that is 3200 into X. This in this way we can get a air external excess. This excess air we can calculate from this formula. The second thing, excess air is there, but theoretical oxygen is needed, because if we have a fuel like carbon, which consists of carbon, hydrogen, sulfur, so we need a sufficient oxygen to give a full combustion of that fuel. So we need a theoretical oxygen. In this case, theoretical oxygen we can calculate with the help of stoichiometric equation again. That is nothing but the O2 theoretical equals to 32 by 12. This is formula, and how this came, just like if 1 mole of carbon requires 1 mole of oxygen, so we can say that 12 kg of carbon require 32 kg of oxygen. So in this way, how much oxygen is required for carbon? That is nothing but the 32 by 12 into carbon. That's it. So in this way, 32 by 12 into C is the oxygen required for the carbon, and then same thing will be there in the second equation. How much oxygen required for H2, how much oxygen required for sulfur in third equation. So in this way we can calculate it all the oxygen required for the carbon, H2 and sulfur. In fuel also oxygen is there, oxygen itself present in there, and that oxygen also we can use for combustion. So that oxygen is we have to minus, because in this case we don't want that extra amount of oxygen from the outside. In this way we can calculate the theoretical oxygen, and after that the same thing, the 23% is there, 23% of air is oxygen, so we can calculate the air theoretical. and energy contained in the fuel. So this is like a input of our energy required. So whatever the fuel is there, we are going to use that energy as a input. So whenever we are going to use efficiency, we need a input energy, and that will be GCV of fuel, is gross calorific value of fuel into fuel firing rate. Fuel firing rate is nothing but the oil flow rate. In this way, we can calculate the air excess, air theoretical, and the total air is nothing but air theoretical plus air excess. So N2 in the air supplied is nothing but the total. So 77% of the air is nothing but nitrogen. So we can calculate the N2 in the air supplied. So total air into 77 divided by 100 is nothing but the N2 in the air supplied. In this way, we can calculate MF, and here A is the surface area of a boiler. So we can calculate it with the help of dimension of the boiler. We will provide that in the manual, and we can calculate that surface area. That's it. These two things are important: flue gas surface loss, and if we want the percentage of the loss, so we can just divide by the input energy required, whatever we supplied as a input, that is nothing but energy contained in the fuel, that is GCV of fuel into fuel firing rate. So we can get a loss percentage of flue gas and surface, and in this way we can just minus subtract it from 100. That's it. Okay, we can go to our actual setup now, and we can check how the flue gas is going to be flow in the actual setup. Just let's go. So this is our boiler, and we are going to start the how it looks like. So in this shell, whatever the tubes are there, it will be inside this boiler, and whatever the water will be there, it's also inside this boiler. This thing is burner, which is used to ignite the fuel. This thing is force draft fan, which is supplied to the fuel, which is going to be mixed with the fuel, and it will be completely combustion. And we can see this tank. So this tank contains the 3 partition. So this is a tank which contains of oil, fuel as well as water. So the last 2 partitions is contain water, and first partition will be for fuel. So this is the water level indicator, and this is fuel level indicator. You can see this one. So this pipe is used to get the oil flow rate for our combustion. So this small pipe will be contain oil, and it will be come to this portion, and this is used to filter the oil. If there is any impurities there, then it can be purify that oil, and it will be passed in this way. This one. In this okay, oil flow rate. In this way, it will be come through that side. It will be coming from this side. So it will be inlet for the fuel. From this we will get a air, and it will be mixed up with the fuel, and it will be here there is spark plug inside the burner, where fuel and air will be mixed up, and it will be ignite, and after that ignition it will be generate the flue gases, and from here we can see if there is a burner is ignited, then we can see a yellow flame from here. Now it's closed, so we can see after that, after the switching on the boiler. So this is whole thing is oil circuit. So in this way we are going to get oil, and we will get a flue gas generation. So now next one is cold fluid circuit. we will go to this next circuit. So we have a water in the tank, so it will flow through this pipe and it will come to this softener, and that this softener will be used to soften that water, whatever the magnesium and all that calcium is there, it will be remove that thing, because it will create the scaling in the pipe or tubes. So we need to remove that thing with the help of softener, and that softening water will be goes again to the tank, overhead tank, that one. So after softening the water will store in the tank. From that outlet of that tank, it will be come through this pipe and it will be inlet into the cell this way. Okay. These are the pumps. If the height of water is going to be down, then we need to feed that water. So we require that pump in that case. Whatever the flue gases will be going to generate in that starting point, that will be passed up to this point, then it will divert the path from this. Here in this portion there are tubes in these two portion, tubes. This is the second path and this is the first path, second path, and after this point it will be goes to the start point, and again it will be divert that path and it will come back to this again third pass, and here also there are tubes and it will be going to be exhaust now. So as we can see here, oxygen sensor is there. So this oxygen sensor will be measure the oxygen, excess oxygen in the exhaust, which we are calculating. This is the digital panel which gives us digital readings. So this gives us 5 main readings, like oxygen, excess oxygen percentage, this one 20.9 now, and this is second thing is boiler pressure, steam temperature, these two, and then ambient temperature is there, oil flow rate which is 0 because of boiler is switch off now, and this is exhaust temperature of a boiler 99.8 now. So here we can get digital readings. So in this the 5 main readings are there. Excess oxygen percentage, that is 20.9 now, then exhaust temperature of a boiler, this one second one, and then the steam pressure, boiler pressure, steam pressure, third one, oil flow rate, fourth one, ambient air temperature. These 5 readings are important for our calculations. Also we can take the stack losses just for our convenience. So how much stack losses will be there in our experiment. So we can take that and compare. We will see on the last conclusion how much it will be there. So calculating the surface temperature, we need to take readings for takes the temperature reading at different location because of variation in the temperature. So we are going to take 5 readings for 5 different locations. First one is here, second one is here, okay, third one is here, okay, fourth one is here, and fifth one is here. In this way we can calculate the surface temperature if we average that all the 5 temperatures. Now we are going to start the boiler, and before that we are going to take the readings for initial boiler pressure, which is now is like 0. This is 1 kg per centimeter, is nothing but just 1 bar. So this is the reading for initial before the boiler start. So now the operator will be start the boiler, and we are going to take the all the readings at 5 bar or 5 kg per centimeter square. So and on that pressure we are going to calculate the efficiency for the boiler. So now operator is starting the boiler. It started now, and now gradually the pressure will be going to increase as the time will go. So now the boiler is started. So now you can see the flame is started. You can see here yellow color flame will be. Yeah, as we can see the combustion is started now. Now the boiler is started, so we are going to wait for certain time, so that the pressure will be reached to the 5 bar. Then after that we will take the readings accordingly. Now we can see the pressure is nearly 5 kg per centimeter square. Now we can take the readings. Okay, let's start the reading to take the readings. Now we can see the oxygen percentage, excess oxygen percentage is 12.5. Okay, then second thing is that boiler exhaust temperature 162.2. The oil flow rate is 168 kg per hour. Ambient temperature is 31.1 degrees Celsius. Okay. So these are the things we are going to use in the calculation. Now we can take the stack losses as well, 10.15 percentage. We can see what's going to be happen for stack losses. Is it useful or not? You can see in the readings. These are the readings. Okay. Now we can take the readings of surface temperature. Now we can start the temperature. Now we can take the surface temperature. Now here we can see for this surface we can use this thermal gun to check the temperature, that is 120 degrees Celsius. Now you can see 121 degrees Celsius surface temperature. Now we can use this location, that is 51.6 degrees Celsius. Yeah, okay. Now we can go to that side. Now this location we will get 44 degrees Celsius, 44.2. Next reading will be this one, 47 degrees Celsius. for this location we got 62 degrees Celsius. Okay. Last we can take the at this surface, so that we get a 6 temperature reading. This is 41.2 degrees Celsius. Okay. Now the surface temperature is we took the 6 readings. Now we can take the average from of these 6 readings, and we can find out the surface losses with the help of this temperature surface and with the help of formulas. Thank you. Now we took all the readings, the surface temperature, the pressure of the steam, flue gases, O2, percentage of excess, and temperature of the flue gases. So now with the help of these readings, T1, T2, T3, T4, T5, T6, we can calculate the TS, that is the average temperature of all the T1 to T6 temperature. And this O2 excess will be going to give us the X number of moles of oxygen in the exhaust gases, and accordingly we can find out the efficiency, the indirect efficiency of a boiler. So this is oil flow rate. The L flue will be going to be, you have to calculate the flue gas loss percentage, surface loss percentage, and indirect efficiency. So with the help of these readings you just calculate it. So in the next session we will going to give you a set of readings in which you have to calculate it, at different pressure you have to calculate a different efficiency, and you have to plot that pressure and efficiency diagrams. That's it. Thank you.
Hello everyone, this is Swapnil, and today we are going to study our boiler experiment, which is boiler efficiency testing. What is boiler? Boiler is a pressure vessel. According to classification, there are two types of boiler. One is IBR boiler and second is non-IBR boiler. Classification wise, IBR boiler is what? Any pressure vessel having capacity more than 25 liters, which comes under the IBR category. For that, we have to follow some rules and regulation to operate this IBR boiler. Now, whatever experiment we are today doing on this, which is doing on the IBR boiler. Our boiler is IBR boiler. Specification of our boiler is mentioned here. You can see. Evaporation rate is 750 kg per hour. Working pressure is 10.5 kg per square centimeter. Hydraulic test pressure is 15.83 kg per square centimeter. Year of manufacturing 2012. There are two types of boiler. One is fire tube boiler and second is water tube boiler. Our boiler comes under the fire tube boiler. Our boiler is capacity having 750 kg. This boiler is 3-pass wetback boiler. In this boiler there are two main parts, which is mounting and accessories. What is mounting? Appliances which are used to improve the safety controls of the boiler, it comes under the mounting. And what is accessory? Accessories are the appliances who are improve the efficiency of the boiler. So the various mountings are there. So what exactly the mountings are? The safety valve is also the part of mounting, which is mounting on the boiler top side. Okay, as you can see, pressure gauge is also one kind of mounting. Inside of this plate there is one fusible plug, which is also part of the mounting. So the front side of the boiler consists of is the burner, which is very important part. It consists of nozzle, spark plug and burner sensor also there. This is the part of burner which is called blower, and this is the fuel pump. So the main part of the boiler is pressure vessel. This is the main part of the shell. which is called shell. Okay. This is also water level indicator. Whatever water inside the vessel, we can monitor on this water level indicator. This is our control planner, which controls all the parameters of the boiler, like feed water pump, feed water level inside the boiler, fuel rate, fuel pump, whatever it is. This control panel control all the parameters for the boiler. This is our feed water pump. One more pump is there, which is on the standby mode. Okay. Next part is fuel pump. As you can see, there is one overhead tank. Front portion of the tank is consist of diesel or fuel tank. We are using HSD here, so the diesel tank is front side, and another second portion is consist of water. And how we can top up the diesel on the overhead tank, that I will show you. This is our fuel pump. With the help of this fuel pump, we can top up the fuel on the overhead tank. This is our top up line. The next part is our fuel line for the setup. This is our fuel line for the setup. Fuel comes from this line to the setup. This is our fuel line. It comes to the filter, then it goes to the fuel meter. This is our fuel meter, and it goes to the burner. This is our fuel circuit. Okay. As you can see, this is our safety valve. There are two safety valves are there. One is front and one is back side of the boiler. So the front side safety valve is set on the 10 kg pressure, and second one, this safety valve is set for the 10.5 kg per hour pressures for pressure. When all the safety parameters are fall to operate on the situation, then these two valves are works and release the over pressure to the atmosphere through this valve, and this line is going to the atmosphere to release the pressure to the atmosphere. There is also one safety valve, which is steam vent valve. This is our steam vent valve. Okay. This is our chimney output. As you can see, this line is going to the chimney back side of the lab. As you can see, this is one kind of a display. In the lab, we are calling it for HMI, human machine interface. So this display the reading of the boiler which are using during the experiment, like stack loss, feed water temperature, ambient temperature, atmospheric temperature, blow down totalizer, steam temperature, boiler pressure, steam flow rate, or oil flow rate, enthalpy loss, whatever parameters required during the experiment, we can monitor on the screen and note down during the experiment. There are also some trends are there. Steam trend also there, blow down trend also there, combustion trend also there, fuel trend also there. So if you want any trend for particular parameter, you can go through it and get it from the device. Okay. So next part is our pressure regulator. Okay. As you can see, this is our water softening device. Whatever water we are using during the experiment, which is go through it and it provided to the overhead tank, because we are maintaining the water hardness for the steam. Whatever water we are using during the experiment, which is around 8 ppm to 5 ppm range. So to maintain the ppm of the water, we are going to use this water softener before the water going to the water vessel. Okay, this is our short ride for the boiler efficiency testing experiment, which is over, and Thank you.